Okay, so this morning we will have the curl of E. Last time class we have the divergence of E and then we have obtained Gauss law. So the curl of E. So for this, we will start with a point charge in the origin. So we know that for a point charge, the electric field is equal to this. E is equal to 1 over 4 pi epsilon naught q over r squared, and then its direction is radial. And then we calculate the line integral of this field from some point A to B. Okay, so for example, we have this point here in the three-dimensional plane. So this is your y, your x, and your z axis. And then suppose this is your point A, and then this one is your point B. So we define r sub A as the distance from the origin to your point A. So this is your r sub A. And then your r sub B is the distance from the origin towards point B. Okay, so this is your r sub B. And then we integrate this electric field from point A to point B. So we can take any path. Okay, so from A to B, we can take any path. And then we have to set up the integral. We have E dot dl. So this is the line integral of the electric field. Now in spherical coordinates, dl is equal to, sige ito, dr r hat plus r d theta theta hat plus r sine theta d phi p hat. Okay, so this is our infinitesimal line in uh infinitesimal length in sa ganina siya spherical coordinates. Therefore, this is dot product siya. So we have 1 over 4 pi epsilon naught q over r squared in radial direction, and then multiplied with the magnitude, or this one, the magnitude of your radial component, which is dr, so among dl. Okay, so we have the integral of E dot dl from A to B is equal to the integral of 1 over 4 pi epsilon naught q over r squared, and then we have dr. Okay, so this is integration with respect to r. So we can actually take 1 over 4 pi epsilon naught out of the integral sign. So we have 1 over 4 pi epsilon naught. And then integrating, you have q. We can take out q out of the integral also. Then we have, this is r minus 2. And then dr. So integral ano niya is, you have 1 over 4 pi epsilon naught. Q, you have multiplied by, so ang galing na siya, minus 1, no? Minus 1 r raised to the power of negative 1 integrated from A to B. Okay. So this is equivalent to 1 over 4 pi epsilon naught. You have Q over R sub B. It should be negative. And then minus Q negative Q over R sub A. So we can further write this as, dali lang natin isulat class. So the integral of E dot dl from A to B is just equal to 1 over 4 pi epsilon naught. you have this one, positive Q over R sub A minus Q over R sub B. Okay, so again, your R sub A is the distance from the origin to point A. R sub B is the distance from the origin to point B. Now, if uh, if R, if okay, so if R sub A is equal to R sub B, then we have a closed integration. So you have integral of the closed integral of E dot dl. This is equal to 0. So as you can see, if R sub A is equal to R sub B, then we will have E dot dl equal to 0. Okay? So you have to take note of this equation. And then we apply Stokes' theorem. So nakay line integral for closed integral of E dot dl is equal to 0 if the integration is closed. If R sub A is equal to R sub B, then your E dot dl is equal to 0. So applying Stokes' theorem, so ganito, recall Stokes' theorem. Who can recall Stokes' theorem, class? Nakay E dot dl is equal to the surface integral. So this is the line integral, and then we can convert it into, or we can translate it into a surface integral. So you just have to get the curl of E and then dot it with dA, so infinitesimal area. So this is equal to 0 according to the previous kinesya. Now this implies that the curl of E is equal to 0. Okay. So if the closed integral of E dot dl is equal to 0, then it follows that the curl of E is equal to 0. So this is true. Kinisyang equation, class, is true no matter where the charge is located. So kaganina natay point charge which is in the origin, but this equation is true no matter where the charge is located. And if we have many charges for a system with many charge, so we have the curl of E is equal to the curl of, say for example, the electric field due to charge 1 plus the electric field due to charge 2 plus the electric field due to charge 3, and so on. So this is equal to 0, or we can rewrite this as the curl of the individual electric fields. So nakay the curl of E sub 1 plus the curl of E sub 2 plus the curl of E sub 3, and so on. Okay, so this is equal to 0. And take note that this is true. This is true for any static charge distribution. So meaning to say, steady ato ang current, static charge distribution. Okay. Now, we go to electric potential. So the electric potential has something to do with the curl of E. So the electric potential is denoted by this one, V, big letter V. The electric potential is a scalar quantity. So the electric field E is a very special kind of vector function. Anong special kind siya of vector function since ang iyaang curl is always zero. So take note that the electric field, when we take the curl of the electric field, it is always zero. We can actually check, if a certain function can be an electric or an electrostatic field by checking if its curl is equal to zero. So kung nakay tagaan ka kuan for example gitagaan ka og function and then you are asked to uh, determine if it is possible to be an electrostatic field, then you just have to get the curl of E. And then if it is zero, then it might be an electrostatic field. But if it is not zero, then it is impossible to be an electrostatic field. Okay, now uh, take note that any vector class whose curl is zero, so this is Helmholtz theorem. I think wala ni siya nato na-discuss sa chapter 1, but this is the last section sa chapter 1. So any vector whose curl is zero is equal to the gradient of some scalar function or some scalar. So that is if the curl of f is equal to 0, then f can be expressed as the gradient, the negative of the gradient of some scalar. So this is a scalar function here. Okay. And then we also take note also that the line integral of E is path independent. Of the electric field is path independent, meaning to say it is conservative. Okay, so it is independent of the path. So the same with work. If you can recall, ninyo class na kay work is equal to the integral of f dot dl. Okay, so this is conservative. It is independent of the path. Independent of the path. Meaning to say, pwede ka moagi bisag asa. For example, if this is your point A, point B, point A, then from here, pwede ka moagi diri, ana, or pwede po ka bisag asa ka moagi class. You will get the same amount of work. Okay? So it is path independent. So the same with your electric field, it is the line integral of the electric field is path independent. So therefore, we can write V sub R. So this is the electric potential as a function of R. This is equal to the negative integral of E dot dl. Suppose this is from 0 to R. So take note that your V sub R here is called the electric potential. Electric potential. Now, the potential difference between 2 points, so say for example, na kay points A and B, na kay nga equation, no? Then we get the potential difference between 2 points A and B. So we just uh, the potential difference. So we have V sub B minus V sub A is equal to, so from this kini siya nga equation, we have negative E dot dl, and then we have from 0 to B, that is our V sub B. So negative integral of E dot dl from 0, or from the origin to B. And then for this one, you have negative of negative E dot dl from 0 to A, or this is plus integral of E dot dl from 0 to A. And this can be written as E dot dl, negative E dot dl. Okay, so pwede ka from the origin to B, and then from B to A. So this is just equal to the negative integral of E dot dl from A to B. Okay? So pareha ra ni sila class. Mura ka og from B padulong kay A, you have or from A to B, you can pwede ka mo gikan sa origin, or gikan sa B padulong sa origin, and then origin to A. Okay? So you can rewrite this as this one. And then according to the fundamental theorem of gradient, if you can recall, according to the fundamental theorem of gradient, na kay, if you have this integral, the gradient of b dot dl, this is just equal to v of b minus v of a. Okay? So this is according to the fundamental theorem of gradient. Kung nakay scalar function, you get the gradient of that scalar function and dot it with dl, or if you get the line integral of a gradient, it is just equal to the difference between the value of your v or your function sa limits. Okay? So, we can actually relate these two. So these two are just equal to v of b minus v of a. So therefore, we can write naa kay integral of the gradient of v dot dl is equal to the negative integral of e dot dl. So since they have the same limit, then it must be nga equal ning integrand. Okay? So these two are equal, negative. So we can write E is equal to the negative gradient of V. So you have negative E here, and then in the left-hand side of the equation, you have the integrand ng gradient of V. Therefore, we have the electric field can be expressed as the negative gradient of a scalar. So the scalar is the potential, or the electric potential V. So you have to take note of this equation. So ito yung meaning ani? So the electric field can be expressed as the negative gradient of the electric potential. Okay? So for example, so we have here a problem. So one of this is an impossible electrostatic field. So which one? So we have two electric field vectors. We have k x y x hat plus 2y z y hat plus 3x z z hat. And then the other one is this. You have y squared x hat plus 2xy plus z squared y hat plus 2yz z hat. Okay, so let us determine if these two electric fields are electrostatic fields, or ang question is which one is an impossible electrostatic field. So take note that K is constant. So K is constant for both. And then for the possible one, for the electric field nga pwede siya mahimong potential nga electrostatic field. For the possible one, find the potential. Okay, so using the origin as our reference point. And then we check afterwards, check by comparing or by computing the gradient of V. Okay, so first we have to know if which of these two ang posibleng electrostatic field. So your E sub 1, so ang ito? So ang ito pag kuan, identify, we just have to get the curl of E and check if it is equal to 0. So we have the curl of E sub 1. This is equal to have x, y, z. Partial derivative with respect to x, partial derivative with respect to y. And then here you have the x component, xy. You have 2yz and then 3xz. Okay, so this is equal to, you have this one. We have to take note nga napaday k, no? K is a constant. So we have 0 minus, this is in differentiating with respect to z. So we have 2y x hat plus, so you have 0, and then differentiating this with respect to x, so you have 3z plus, you have 0 minus differentiating with respect to y, so you have x. This is z hat. Okay, so this is not equal to 0. Therefore, your E1 is an impossible. Impossible siya nga electrostatic field. Now, how about the second electric field? So we have y squared x hat. Again, we just use the basket method to find the curl of E. So this is equal to K. You have x hat, y hat, z hat. And then you have y squared you have y squared and then 2xy plus, is it plus? 2xy plus z squared and then 2yz plus z squared and then 2yz. Okay, so we have k multiplied by, so the x component is, you have to differentiate this with respect to y, so you have 2z minus this one. So differentiating this with respect to z, so you have 0 and then 2z plus your y component. So we have differentiating this with respect to z, so this is 0. And then this one, differentiating this with respect to x, this is equal to 0. So the y component is 0. And then for your z, we have this one, no? Yun siya. Differentiating this with respect to x, so you have 2y minus differentiating this with respect to y, so you also have 2y. So this is your z component. Therefore, the curl of E sub 2 is equal to 0. So this is a possible electrostatic field. So it is a possible electrostatic field. After this, for the possible one, find the potential using the origin as your reference point. Okay, so for this, what we will do is we get the line integral. Okay, in order to get the potential, we need to integrate. So, kini siya itong gamiton class ng equation. This one. So, V sub R is equal to the negative integral of E dot dl. And hence, we must choose an integration path. So, suppose the path is, say for example, let us take the path as this. So, y, x, z. Okay, so suppose this is our path. Path number 1. And then 3. Path number 2. And then pasaka dayon si path number 3. So diri ato ang gikan sa origin padulong ani. So suppose this is x naught, since wala man siya nag-ingon sa limit, no? Let us just suppose that this is your x, y, and z naught. Okay. So this is your path number 3. So let us integrate each. So for path 1 class, to mag-integrate ani with respect to y, no? So for path 1, your x is equal to z, which is equal to 0. Therefore, dx is equal to dz is equal to 0. So we will be integrating only with respect to y, since si y kay nag-change siya og value from the origin towards, this is your y naught. So y is, asa ganun na siya? From 0 to y naught. Okay? Therefore, your E dot dl is equal to k. So, balik ta sa ito ang function class. Nalang tay kung ano? Y hat component or y component sa ato ang DL. Therefore, kinilang siya, this one, 2xy plus z squared. Since this is a dot product. So, ang DL na to kay dy raman. Kay 0 man na tong dx o dz. So, natay dy. Okay. So, E dot dy or E, ang atong component, y component sa electric field is 2xy plus z squared. And then you have dy here. Supposedly, we have to integrate this from 0 to y naught, but here, our x is equal to 0 for path number 1. Our z is also equal to 0 for path number 1. Therefore, E dot dl is equal to 0. So integral of 0 is 0. And then for path number 2, kini atong path number 2 no. So let us see kung unsa ang ga-change diri nga variable. So y is equal to y naught. It is constant equals y naught. And then ang nag-change is si x from the origin towards x naught. And then your z is also equal to 0. So for path 2, class, are you following? For path 2,
Yes,
you
ma'am.
have y equals y naught. And then your x is changing from 0 to x naught. And then your z is equal to 0. Okay? So, meaning to say, we will be integrating, or we will have dx as our dl. dl is just equal to dx. So from our function, ang x component is y squared. Okay. So we have E dot dl is equal to y squared multiplied by dx. Okay. And then integrating this. Now take note ha, nga si y is equal to y naught. So we can actually write E dot dl, integral of E dot dl from 0 to x naught is equal to integral of y naught squared. So y here is constant. It is equal to y naught. And then you have dx from 0 to x naught. Therefore, you have y naught squared multiplied by x naught. So this is our E dot dl or this is our V for path number 2. So for path 1, the potential is 0. Path 2, our potential is y naught squared x naught. And then for path 3, let us see. So for path 3 class, kini siya no? So ang change is ang z. So z is from 0 to z naught. And then your x equals x naught and y is equal to y naught. Okay? So we have y equals y naught, x equals x naught, and then your z is changing from 0 to z naught. Therefore, we will be integrating with respect to c. So we have E dot dl is equal to itong x component. So you have 2yz. Okay. 2yz, integral of 2yz, where y is equal to y naught. So I can just write this as y naught, a constant. And then you have dz here. So this is from 0 to z naught. All right. So you have 2y naught, integral of z dz from 0 to z naught. So this is equal to 2y naught. So gani integral anin niya class? 1/2 of z squared from 0 to z naught. Or this is equal to y naught z naught squared. Okay. Therefore, our potential, the potential is Take note that potential is a scalar function. So you have V is equal to 0 plus y naught squared x naught plus y naught z naught squared. Okay, so this is our potential. So this is our potential as a function of x naught, y naught, z naught. Or we can generalize this as v as a function of x, y, z is equal to y squared or xy squared plus yz squared. Okay, so this is our potential, and then we are asked to check. Lah, napa ni mga k class? It should have k. Nani siya k dapat k. Yeah, we can distribute k. Sorry. Anyway, k is just a constant, so for path number 1, correct na patay gibutang nga k. For path 2, this should have k here. Nani siya k diri. So this is k y naught squared x naught. And then the same with this one. Dapat nani siya k diri. K. So you have k y naught z naught squared. So you have k here. So we can factor out k. We have k x y squared plus y z squared. Okay. And then after this, we have to check if this potential is correct by using this equation. So to check, we just have to get the negative gradient of v. So this is equal to minus the gradient of v. So once again, gradient class, this is equal to partial derivative of x hat plus partial derivative of v y hat. So this is v plus partial derivative of v z hat. Okay. So na kay negative, you have k. Pwede na ito ipagawas daan si k since common siya anin nilang tulo, no? You have partial derivative with respect to x of our function. So, unsa kita itong vector scalar function, xy squared plus yz squared. Xy squared plus yz squared. X hat plus, pagawas na to daan si k kas ha, partial derivative with respect to y of kini siya gihapon rv xy squared plus yz squared y hat plus the partial derivative with respect to z of xy squared plus yz squared z hat. Okay, so we have minus k, and then inside we have here integration with respect to x. So this is y squared x hat plus the y component integrated, differentiated with respect to y. So this is 2xy plus z squared y hat. And then plus, you have here with respect to z. So this is 2yz z hat. Okay. So let us check if this is the same as our pareha ba?
Parehas, ma'am.
Pareha, no?
Pero anong negative, ma'am?
Negative siya. Okay. Sorry. Be, aha man ta nagkamali. Let us look at haha. Okay. Take note class that V is equal to negative E dot dl, no? V is equal to negative E dot dl. So, ang ato din gikuha diri kay integral of E dot dl man, rano? Integral of E dot dl. Integral of E dot dl, integral of E dot dl. So, kung magkuha tag V, it should be minus the integral of E dot dl. So, this one, since gi-equate man ni siya nako as V, this should be negative. Pero kung integral of E dot dl lang unta, this mo ni siya to ang makuha, k y naught squared x naught. And pwede na din ta diri magbutang og negative sign kung mag-construct na ta sa atong V, but kini siya kay gi-equate man siya nako as V, so I should put a negative sign here. So kini okay ra ni siya. Integral of E dot dl equals ky naught z naught squared. But if I am going to write this as a potential, dapat negative ni siya diri ug negative po ni siya diri. Okay ra? Okay ra sa inyo a class na na-follow ra ninyo kung asa ta na mali?
Yes, ma'am. Yes, ma'am.
Okay. So this should be negative. Negative ni siya diri. Therefore, kung mag-check ta na may negative sign daan ang kung ano, negative gradient of B man dun ni siya, E is equal to the negative gradient of the potential, the electric potential. So therefore, ang atong V kay kuan man ni siya, negative, di ba? Negative man itong V. Negative of a negative potential, we will have positive. So, pagpagawas na to kay K, dapat kay negative K din nga itong ipagawas. Negative K. Negative of negative K. So, negative, gikan sa equation daan, and then negative man po itong potential, so ipagawas na to ang negative sign along with K. So, you have negative of negative K multiplied by this. So, this should be positive. Sorry. Okay? So, this is correct. Okay. So, dili lang sa tataman karon class. Alright. So, any questions? Okay ra mo
Wala,
na.
ma'am.
Nakuan ba to, no? Na-resolve na to, no? Kung asa to na mali. So, B is equal to minus integral of E dot dl. Okay? So, again, class, ang inyo ang midterm exam, wala pa dun ako na-checkan. Okay? Di na lang ako mag-promise. Okay, pero excited ko sa inyong grado. So, see you on Wednesday.
Thank you, ma'am.
Sige, sige.
Sige, ma'am.